Hello everyone, welcome to Data Discovery. At this video, we are going to see the project related to NLP, that is nothing but natural language processing. So, by using that, we are doing the project called email classification. Whether the email that we are receiving is of spam or not spam, that we are going to classify it. So, based on that, we will be doing the project. So, this is completely based on NLP techniques that we will be using, like NLTK tokenization techniques, all the pre-processing techniques, the padding techniques, and then stemming, etc. Things we will be doing it, and then after we will be building a model. So let's start with the project. So first we need to start with the importing libraries. So all the necessary libraries, that whatever will be needed, we need to import it. So this will be the basic libraries like NumPy, Pandas, Matplotlib for visualization and TensorFlow, because we are doing with the deep learning techniques. So for that we are doing a TensorFlow, and then after all the pre-processing techniques, all the NLTK tokenization, padding sequence, all the rejects that we need to import, and then after for model building, whatever the techniques, that is dense embedding, LSTM, dropout layer, and the sequential. So this all we have imported it. Now let's start with the reading the data set. As I'll just show the data set how actually it looks like. I'll be sharing my GitHub link at the description box. You can get the project link. This is how the training data set looks like. Here we have train data, test data. I will be sharing all my GitHub link, like notebook and the data set at the description box. You can clone my GitHub and you can do it in your system also. First, let's see the training data set. Over here, it's very important to encoding into Latin, because there is most number of the term that I have seen, it's present in Latin. So for that, we need to do it in encoding, because it's suppose a non-ASCII keyword. While I was reading the dataset without encoding, I got the error. So I got the techniques called encoding Latin one. So once I done with it, the I got the clear with the error. So this is how we need to do it. Here I have just using the train data set in which I'm reading the data set. Here you can see it's in form of classification format. It's of non-spam and spam. Only two labels is there. So we can do the encoding, label encoding techniques, and we can change it up. But in message, whatever has been represented, okay, that is some kind of the message body that I have seen. It's of 2-3 lines also. So we need to do the stemming by using a stop words, by using a data cleaning, etc. techniques, and then after we need to encode from text to vector. Okay, so this all we need to do it. Here this is my testing data. From my training data set I have around 1000 rows, and for testing I'm having around 125 rows. Okay. uh, Okay. First, let's start with the data cleaning and data pre-processing techniques. We need to drop the serial number column, and label needs to be included. Okay, the serial number, it's not at all needed for building a model, and label needs to be encoded. Okay. And then after, I have just mapped the values, like spam is represented as 0 and non-spam is represented as 1. So same thing will be happens with the testing data. Okay, all the encoding techniques, that whatever you are doing with the training data set, same thing you need to apply for the testing data set also. So for that, this is for training and this is for testing data set. So the data set that I'm using, it's already trained and test split once. So while we are creating a model, we used to use a train test split thing, but over here it's already, we have separate data set. Okay. And over here I have just dropped the serial number for if the appears for both training and testing data set. Now we were using the stop words, the inbuilt stop words. Even you can create your own stop words also, but I'm using the inbuilt stop words of English, in which here some of the data set that I have seen, like in message body, if I will be seeing in every specific rows, I got some kind of link also. Though I'm not interested on it while building a model, so I have just vanished it off. I have splitted it. So if for example it's been represented as hello, I'm Sharanya, do you subscribe to Data Discovery? So it's been present like that. So over here the exclamation marks, the inverted commas, each and everything will be removed. So this is our own cleaning data set we have imported in our own. Okay. Okay, and the same thing appears for the training and testing data set, as I've said. So I have dropped the message body. So over here the message body is also there, label we have encoded, and the text part we have already cleaned, the data set has been stored. Now the message body will be not at all interested, so we have dropped it. So now we need to encode the text ones. So we started with the encoding techniques. First we need to tokenize is nothing but I'm converting the sentence into words from single parts. I'm just creating, okay, and then I'm fitting into a training data set, and then after I'm just converting into a vector format. Okay, by using a padding techniques, pre-padding, post-padding techniques, we can do it. Okay, and then after we have converted into a vector. So as I need to say that while training a model, if for example my first row, you can see only three values is there, 1 to 3. Okay, and my second, my values is comparatively higher than first. So while we are encoding it, so while having this one first row, you will be having more number of values, because the more number of words, more number of encoding, it will be converted into a vector. But less number of words, even the values will be also values we couldn't able to say, like the terms, the dimension will be comparatively less. So while training a model, we couldn't able to train because dimension is different for each and every rows. So for that, what we will be doing, we will be using some of kind of the zero values, like for example, only three words is there, right? So rest all words as per the maximum words, it will compare with it, and then after it will be placing in the format of zero. Okay, so that each and every rows contains equal dimension. Otherwise, while training a model, due to different dimension with different number of rows we have, it will be affected. So over here we have using the padding sequence, in which I have truncated into all the start. You can even do the zero at the end also, it's up to us, but I have done with the pre ones. So we need to convert into a same dimension, because one with two dimension, another with five dimension, while training a model will be affected. So for that, all the two dimension, if my maximum dimension is 5, so some of the row contains two dimension, so the beginning one, the first three values will be converted into a zero, and then the two dimension values will be there. So this is how we are just representing of. Let's start with the model building, is the most important part. All the techniques that we are doing, like cleaning, data pre-processing, and the encoding techniques, it will be most important for model building. So over here I have done the sequential model by using a dropout layer, lstm, dense, etc things. And the most important, by compiling it, I'm using a loss technique called binary cross entropy, optimizer, adam, and metrics of accuracy. So you can use any optimizer, but I have just tried out. Anyways, we will be dealing with what all optimizers have, and which optimizer need to use at what techniques, etc things. Anyways, we'll be going through it, but over here I have just used done the simple ones. Okay, the model dot summary history, we can see as history have given the 5 iteration. Epochs will be epochs I have took it as 5. Actually I have tried with 10, but I haven't got the actual accuracy. Means the by using a 5 accuracy also, 5 epochs also I've got the better accuracy. As you can see, the accuracy will be present over here. Okay, 86, it's been improving. 96, 98, 99, 99.6. Okay, it's been increasing, so my model is performing well. Even my validation loss should be decreased. So you need to identify while doing with the history, when we are doing that model dot fit for very large model, within an early stage itself you will be getting an idea whether my model is working it properly or not. If my accuracy is increasing and my validation loss is decreasing, so I can say that my model is performing well. So as we have seen that accuracy has been increasing, this will be my training data and this will be my testing data. So while I was checking, it's almost same. We can see it, over here it's 50 percentage over 80 percentage, 85, and over here it's almost coming to 80 percentage. And then as the epochs increase, even my models also increasing, and over here the loss is decreasing. This is what I need, right? Loss need to decrease and accuracy need to increase. So I have completed with the model building and the testing, and which is performing well. But I have done some other techniques called also data distribution. As I've seen that my label, that is nothing but spam and non-spam. So the non-spam values is comparatively higher than the spam. So sometimes some of the data set or some of the model building techniques, whenever you're using it, you will be getting very less number of accuracy because of data distribution. As over here we have around 800 rows or around 1000 rows we are having. So based on that we are doing a model building. But if you have n number of rows like lakhs, 4 lakhs data set, as I have one of the data set, I have in one of my project I have trained around 4 lakh data set, in which around 100 rows only having the classification was like that, 100 rows like that. And my 4 lakhs data set is showing something different. So because of the data distribution, as you can see that it's having a large number of changes, it's having a large number of difference, we can say. So because of that my model building, while creating a model building, my accuracy got affected. So at that moment you need to almost, the data distribution should be almost same. So you can use the undersampling techniques, oversampling techniques by using that. Otherwise you just as over here we have around 800 rows only. So I have just removed some of the rows, I have brought some of the rows. So based on that I have just used the model like around 2 to 300 rows I have just deleted from my one label. So based on that I have used it. So whatever the data it's been stored after removing it, and then after I have trained it, it's performed well comparatively before. So this is some of the technique I've just given a small hint that by using a data distribution, this is how the data distribution like. So our project actually completes over here, but I have just given the techniques. Like once you're not getting a good accuracy, this will be a small tips like see the data distribution. So once the data distribution it's not looking properly, then do the oversampling, undersampling techniques, and you just do it well. So here we go. Thank you for watching this data discovery, and I will be coming with more and more videos related to data science stream, the NLP techniques, all the Python coding, etc. things. Do like, share, and subscribe to the data discovery.